Now we're getting to a little bit more of a difficult proof. This one requires multiple steps. So let's look at our given. Our given tells us that we have QR being congruent to TS, so indicated by our dash marks, and also that QR is parallel to TS, indicated by our triangles. So it only tells us one side being congruent to the other. So we need to figure out two things instead of one this time. So right off the bat, I'm just going to go ahead and say QT is congruent to QT because of the reflexive property. And this is where it gets a little bit more difficult. We're going to have to apply what we learned in the previous chapter. So thinking back to parallel lines, I know that I can prove angles are congruent in parallel lines by a couple of theorems. And seeing that our parallel lines are here and our triangles are both on the inside of our parallel lines, I know I'm going to use the alternate interior angles theorem because it's on the interior of our parallel lines, and I know alternate interior angles are the same. So I'm going to go ahead and write that this angle and this angle are the same by alternate interior angles. Now, when I'm writing those over here in my statements, I'm going to go from one side to the other. So I'm going to say angle RQT is congruent to angle STQ. Remembering that the middle letter is always the point in our angle. Okay. So this is by alternate interior angles. Now I have a side, an angle, and also another side. So I can go ahead and assume my triangles are congruent. QRT is congruent to TSQ. And I know that by side, angle, side.